Hello friends, subscribers and new viewers of this channel. In this tutorial we explain how to correctly install Meta Segment Anything Model 2 or SAM2 algorithm in Python and Linux Ubuntu and how to write an object detection and tracking script in Python. We have also created a tutorial on how to install SAM2 in Python and Windows. A link to that tutorial is given in the description below. The Linux Ubuntu installation of SAM2 is actually much simpler compared to the Windows installation. This is probably because the developers of SAM2 used Linux Ubuntu or some other Linux distribution to develop this amazing algorithm. Here is a brief demonstration of SAM2, and by the end of this video tutorial you will be able to write a Python script that will do something similar, of course on the basis of the video that you will provide. So what is the goal over here? The goal is to detect and to track this coyote, and over here on the right hand side you can see the original video. And this video, or better to say the frames of this video, are the input to the SAM2 algorithm. Then, we simply take one of the frames of this video and we can simply just point out to SAM2 2 points on the body of coyote. That is, we will simply select 2 points, for example this point and this point, and this is enough for SAM2 to be able to detect, segment and track the coyote, and the result is shown over here. You can see how the coyote is being completely masked and segmented from the background. This is really amazing. Then you can even track some of the points on the coyote's body, or you can even change the color of the coyote, or you can do all sorts of things. This is because we are able to distinguish coyote from its surrounding, and this is truly amazing. SAM2 algorithm can have a number of applications in robotics, computer vision, and in other fields. But before we start with explanations of the installation process, we first need to explain what are the software and hardware prerequisites for properly installing and running SAM2. So let's start. First of all, you need to have Python version above 3.10. Python should come with Linux Ubuntu installation. If you don't have this version, either install it or install newer version of Linux Ubuntu. That is, if you have 22.04 or a version with a larger number, then it's fine. Then, you need to have a relatively new GPU. We have NVIDIA 3090 GPU with 24 GB RAM. We also tried NVIDIA 2060 Super, and the computation is at least 4 to 5 times slower than computations performed by NVIDIA 3090. Of course, I think it's possible to also run SAM2 on a CPU. However, I've seen it that it's very slow. Then, you have to install NVIDIA CUDA Toolkit from the official website. Both CUDA Toolkit and PyTorch should be installed separately, so keep in mind this. To install CUDA Toolkit, you need to visit this website and you have to strictly follow the procedure. Also, you have to make sure that after the installation, CUDA path is properly set in the .bash rc file. We created a separate video tutorial on how to properly install NVIDIA CUDA Toolkit in Linux Ubuntu. A link to that tutorial will be given in the description below this video. Then, you need to have a GCC compiler installed on the Linux Ubuntu system. Fortunately, GCC compiler comes with the standard Linux Ubuntu distribution. However, we will still double check this. Then you need to install FFmpeg command line audio video tool for extracting image frames from videos. We created a separate video tutorial on how to do that, and see the description below. The download page for FFmpeg is given over here. You have to strictly follow the instruction in that video and make sure that you test FFmpeg before you actually use it. Optionally, you can also install VS Code or the Visual Studio Code for editing Python files. I really like VS Code and I strongly suggest to everyone to use it. However, you can also use some other Python editor to edit and execute Python files. To summarize, we created tutorials on how to install the necessary prerequisite software. Links are given in the description below. And just for the summary, we are using CUDA Toolkit version 12.6, that's the newest CUDA Toolkit version, and we are using Python 3.10. Okay, let's start with the explanation. We will start with the initial step, that is step 0. In this step, we will make sure that we have all the necessary software. Open a terminal, and over here I will resize this terminal such that you can see what I'm typing in the terminal. At the same time, you can see my manual over here. The first step is to verify that we actually have a GPU on our system. We do that by executing this command, and over here you can see that I have NVIDIA GeForce RTX 3090. Then this is the driver version, and this driver version is based on CUDA version 12.2. Notice that this is actually not compiler version. You have to have a separate compiler to run SAM2. So let's verify that you actually have a separate compiler. You can do it like this, and you should see something like that, like this. CUDA compiler driver, copyright, and over here you can see that I have 12.6. This is the recent CUDA driver that's installed by installing NVIDIA CUDA Toolkit. I provided a separate video tutorial explaining how to install NVIDIA CUDA Toolkit in Linux Ubuntu. The installation process is not trivial. Okay, let's proceed further. Next, you have to verify that you have the correct Python version. You need to type this. And notice that I have Python 3.10.12 and I'm running Linux Ubuntu 22.04. Python comes with Linux Ubuntu 22.04 and the Python version is 3.10. If you see some other version of Python, then you need to install, for example, Python 3.10 or Python 3.12. And you can easily do that. That's not an issue. And notice that you need to execute Python like this in Linux system. Next, we need to make sure that we have the proper C++ compiler. We do it like this. And over here you can see that I have GCC compiler, and this compiler actually comes with Linux Ubuntu distribution. That is, it's an integral part of the Linux Ubuntu distribution. The next step is to clone or to download the remote SAM2 repository and some other files. So again, open a terminal, then go to the home folder. We do it like this. This tilde here is an abbreviation for the home folder, and inside of this folder you need to create a new folder and call this folder codes. That is, you need to execute this command. I'm not going to execute this command since I already have codes folder, however you need to do that. Then you need to navigate to the codes folder, and over here in this codes folder we will create a subfolder for our package. I'm going to call this folder SAM2 and I'm going to create this folder like this. Okay, so let's now navigate to SAM2, and of course it's completely empty, and in this folder we will clone the remote repository. To clone the remote repository you need to know the address of this repository. So to find the address you can Google SAM2 Microsoft or Facebook, sorry, and then you will see this page, and you need to copy this address. This is very important. And then this address is actually given over here, and you simply need to type git clone this address. So let's do that and make sure that you're in this folder, and let's do. Okay, and now this is relatively quick since the files are not too large. However, the story doesn't end there. Let's explain the next step, but before we do that, let's see the structure of the new download. So, okay, we can see that we have a subfolder called segment anything. So let's go to that folder, and here it is. All the files over here are the exact copy of the current version given over here. Okay, so we can continue from here. Next, we need to download the necessary model checkpoints. So what are the model checkpoints? Model checkpoints can be seen as frozen models in time. That is, during the training process, someone will save the model, that is, it will save all the weights, the network, and everything. Okay, now, before we actually download the model checkpoints, we need to make sure that we have wget. Wget is a very convenient tool for downloading. First of all, run this to update and upgrade and enter your password. And then make sure that you have wget by executing this command. As you can see, I have it already here, and most likely you have it since it comes with Linux distribution. However, always double check. Now, there are several ways to download the checkpoints. Let me show you remotely where the checkpoints. If you click here, you can see this script over here. So let's open this script and let's see what's written over here. Well, this script will actually automatically download the checkpoints, and we can execute this script locally from our computer since we have everything on our computer. Here's SAM2. Here's the folder, and we just need to find the checkpoints, and here's the script with the checkpoints. Now I will open this one and you will see what's happening over here, and that's precisely this file over here. So let's go back and let's analyze what's written over here. This script will actually, first of all, define this URL, and then on top of this URL, we'll add the checkpoints files. And you can see base URL plus the checkpoints files. Here they are. And then it will try to download them by using wget. Here's what's happening. And it will download all 4 model checkpoints. And you can see there the model checkpoints for the tiny model, for the small model, for the base plus model, and for the large model. Okay. The first approach for downloading these model checkpoints will be to actually execute that script. Okay, so let's do that by typing this to go to the checkpoints folder, and over here we simply need to execute this script. We do it like this in Linux. And hopefully this will work. And okay, it's working perfect. Now, I was not able to do this in Windows, and I had to manually install. However, since whoever wrote this script wrote it for Linux Ubuntu, it works perfectly. No problems. However, I will also explain you how to download the model checkpoints if you cannot run this script. Let's wait for this thing to complete, and you can see that this large model is around 1 gigabyte, so it's very large. If you now type ls-la in this folder, you will actually see that besides this download script, there are 4 models, or better to say model checkpoints. This means that we have successfully downloaded. However, if for some reason you cannot execute this script, here's a backup option. The backup option is actually to look again into this download script, and you can simply take this base address, and on top of this address you can add the model, and then you can simply copy and paste this complete address in your web browser, and the download process will automatically start. So let me show you this just as an example. Over here I already have the addresses, so I'll simply take the base address, and for example on top of that I added SAM2 here a tiny, which is basically the complete address. I will go here, go to my web browser, do this, and press enter, and you can see the download process starts. Then you will simply go to the downloads folder, then you will simply copy and paste this file, and you're going to paste it in this checkpoints folder. So simple as that, not a big issue. In the next step, we need to create a Python virtual environment and to install all the packages and build SAM2. But before we actually do that, let me explain you one very important thing. It's a very good practice to install everything in Python virtual environment or in an Anaconda virtual environment. The main reason for that is that by creating a new virtual environment, you kind of decouple your installation from the base Python environment and all the packages in the base Python environment. This gives you a great opportunity and an environment that you can actually test your code, and you can manually install all the packages without worrying about package conflicts. Because if you would now, for example, install all the new packages that you need to run SAM2, and for example, you're using some older version of packages that are necessary to run some other program, you will create an issue. Because if you update all the packages, maybe that old program will not be able to run with new packages. And consequently, always decouple your base Python installation with your virtual environment. That is, always do installation in a virtual environment. Okay, so let's learn how to do that. First of all, make sure that you're in this base folder over here. And let's make sure that you're here. You should see all the files, good. And then in this folder, we will simply create Python virtual environment by running this Python 3. V is the command for virtual environment, and I will call the virtual environment as SAM2. Good. The next step is to activate this virtual environment, and we do it like this. And now magic happens. You can see over here that you have SAM2. Next, let's start with the installation of packages. But before we do that, let's analyze our complete repository that's downloaded. Now, over here, whenever you see in the repository setup.py file, this is actually a file that defines how the package or how the complete repository is installed. So always open this file and read it carefully. The most interesting part is this one. You can see the required packages, and these are the required packages as well as their versions that are necessary to successfully run and install or install and run SAM2. You can see Torch version, Torch Vision, NumPy, and some other packages. And then over here you can see the extra packages. Here they are, good. And you have this very important function. This function is maybe the most important part of this setup script. It will actually compile CUDA, or better to say, it will compile some files in SAM2 by using the CUDA compiler. And most of the problems come with this part over here. At least on my Microsoft Windows machine, I had to override this and to do all sorts of things to be able to build. However, as you will see over here, the installation is much simpler on a Linux Ubuntu machine. So, let's start. The best approach to actually install everything is to run one magic command. And let me explain you that command. That command is actually this command. Okay, so if you run this command, everything will be installed and built. First of all, the packages will be downloaded, PyTorch will be downloaded, some other packages, and then you will build the complete system by using CUDA compiler. Okay, so let's execute this. Now, before I actually execute this command, I will run this command. Oops, let me now type it here. Python 3 with an option M, pip cache purge. Okay, so what will happen right now, I'm going to completely purge my cache of pip. This is because sometimes if you open install or uninstall something, some parts of the packages will be left in some other folder that's kind of default to Python. And it's always a good idea, if you want to have a completely fresh installation, to run first of all this command. And after you run this, you need to run this one. So you write pip install with an option E and dot or period. Don't forget this, and let's run. Now, this will take probably 5 to 10 minutes. This is mainly because PyTorch is a very big package. And on top of that, once you install everything, you will need to basically build everything automatically. That is, CUDA compiler needs to be called and some C++ code files need to be built. And this is run in the background, so be patient over here. Even if you don't see this progress moving, something is happening behind the scenes. So wait 5 to 10 minutes. On the other hand, if you already have cached everything, that is, if some packages are cached, then this might take much faster. However, most likely this will take 5 to 10 minutes. Okay, so after approximately maybe 4 or 5 minutes, everything is done. So now make sure that there are no errors by just scrolling all the way up. There are no errors. Good. Perfect. The next step is to execute this command. However, don't blindly execute this command. Let's see what this command will actually do. So again, let's go to our setup file, then let's open it up and let's see. So if we execute this command, we can see that with the option demo, we are actually installing matplotlib, we are installing Jupyter, and we are installing OpenCV Python version. This is very important that we are installing OpenCV and matplotlib. Jupyter is actually not important for my video tutorial. However, you can use it if you want to use Jupyter. However, I can even erase this. So by running the command that you can see over here, we are actually going to install this. Good. Let's not change anything and let's just run this command. And you can see what's happening. Okay, now be patient over here. As I mentioned previously, I was not able to smoothly install SAM2 in Windows. And during the execution of this command, I got a number of errors. I solved that issue like this. First of all, I ran pip install setup tools. Then I installed PyTorch by basically going to the PyTorch website, clicking on stable, choosing here appropriate version, and choosing and copying actually this command, then executing this command to install PyTorch. Then after that, I had to run pip install matplotlib, pip install OpenCV Python. Then I was running this command. However, this was for Windows. As you have seen right now, there are no issues on Linux Ubuntu. However, if something happens, follow this procedure. That is setup tools, then PyTorch, then matplotlib, then OpenCV. And this should solve the problem. And then after that, you will be able to build everything. Okay, this is very important. Let's continue. What is the next step? The next step is to create our folder where we are going to store input images, that is the input video. To do that, let's create a folder inside of this base folder. First of all, let's make sure that we are in the base folder by executing this. Then let's create the video folder like this. And in this folder, we will actually copy our video. So I will do it like this to save some time. Here's my video. And then I will simply copy it. Then I will go to Home, Codes, SAM2, Segment Anything, and I will copy it over here. Now, go back to the terminal and make sure that the video is there. Good. Then, we're going to extract the frames from this video. Notice that SAM2 is actually using frames to perform object tracking and detection. To extract the frames, we will execute this command. We will call ffmpeg, then we will specify the input video, and over here we need to specify this parameter. We need to specify the start number of our extracted files. So the files are going to start from 0 and they're going to be formatted like this. That is, they're going to have 5 decimal places and there'll be integers and the extension will be JPG. So let's execute this. Again, to execute this command, you need ffmpeg or ffmpeg, and I created a separate video tutorial on how to install this very useful tool. So now if you run this command in this folder, magic will happen. Okay, let's see what happened. Now we have 341 files. So let's see these files over here. Wow. So why do we have 341 files? Well, we have 341 files since the video is approximately 11 seconds and the frame rate is 30 frames per second. And this gives around 341 files. These files will be the input for our SAM2 algorithm. The next step is to create another folder. This folder will actually store the output images produced by SAM2. First of all, let's go back to the base folder. You can do it like this or simply typing cd with a double period. And inside of this folder, we are going to create another folder called output. And let's see that we have that folder. So where is the output folder? It's here. Good. The next step is actually to code. I'm going to use Visual Studio Code. So make sure that you are in the base folder, and to start Visual Studio Code, I will type this. And here it is. I like it a lot. Okay. Now, I created a video tutorial explaining how to install Visual Studio Code in Linux Ubuntu. A link to that tutorial will be given in the description below. Let's create a new file, new file, and I'm going to call this file as test1.py. Here it is. And here. Now, to save time, I will simply copy and paste the file that I previously wrote, and I'm going to explain that file in details. So here's the file. So I will copy it, then I will go to my Visual Studio Code, I will paste it, and let me explain this file. This file is partly based on the official demonstration file provided on the GitHub page. However, I made significant modifications of this file, so I've rewrote most of the parts. So let's start from scratch and let's explain every line at a time. Over here we import OS, we import PyTorch, we import NumPy as NP, then we import matplotlib for plotting, and over here we import Pillow library. Pillow library is an alternative to matplotlib. And over here we actually import the part of SAM2. We will need this object or this function build SAM2 video predictor. Okay, and then over here I import input output. Here we set float 16 for the entire network. Over here, we perform a simple check to verify if you have Ampere GPUs. If you have, then we set these parameters. I have NVIDIA 3090, which is not Ampere GPU. At least I think it's not. So this will not be relevant. However, just keep it as it is. Next, here are the model checkpoints that we need to define. Okay, this is a very important step. So let's now understand what's happening here. Let's go back to our repository. It's home, then it's in codes. Let me just navigate. Then it's SAM2 here, and here are the checkpoints. We need to specify a path to these checkpoints. So first of all, I listed all the checkpoint files, which are actually the memorized model, and we need to define a path and the absolute path to these checkpoints. So if you see over here, here is the path to the large model, right? And you can change this path and use any other model as you wish. You just need to change the part over here. In addition to this, there is another thing. Every model checkpoint has to be matched with the configuration file. Here are the configuration files. If I chosen this model, I have to choose this configuration file. So where are the configuration files? Go to the files, go here, and here, if you click, you can see the configuration files. Let's click on these configuration files to see what they are. Well, they define a lot of things. They define, you can see memory encoder, they define the parameters of the memory encoder, they define the parameters of the memory attention, very important configuration files. And you can play with the parameters inside of these configuration files to optimize your network. This is very important. Again, if you, for example, choose another model, for example, base plus, you will need to choose this configuration file and you will have to write it here. This is very important. Now, if you don't know how the path is being defined, or if you're writing this script on your computer, notice one thing over here. I'm using my username, so this path will not work for you. You have to use your username, and the best way to do that, go back to the terminal and type this, pwd, and you can simply copy and paste this base path with your username, and you can use it here and then add this file on top of that. Good. Over here we need to create the predictor object. So what do? We create the predictor object by specifying the model configuration file and specifying the model. That's it, simple like that. Next, we need to create our mask function. So here it is. So what this mask function is doing, it's actually creating a mask on the image. And this is very important. That is, at the end, we will mask our coyote once we detect it. So you get mask, axis, object ID, random color. Then you do a few things over here. You concatenate, you create CMap, you create CMap index, you create an array storing colors, then you get your mask, horizontal, vertical, then you create mask image, mask.reshape, you do this, and that's it. And then you basically show the mask. Then you have another function for showing the points. I will explain how the points are defined and what will happen once I define this function. So here you will simply show the points based on the coordinates, labels, axis, and marker size. Here you can play with the marker size, and over here you will extract position point, the other points, and you're going to use scatter function to plot the points. The next step is to define the path of our video. You just need to define the path of the video and not the file that you're actually loading. Okay, this is because we are going to load all the images. So let's see the path. So let's go to the video and type pwd to see the path, and here it is. This path should perfectly match the path over here. Let me now show you. Two paths are identical. And over here we scan all the JPG files in this folder, and we store them, and we sort them over here. Okay, now what happens over here? Over here I'm simply going to actually image, or better to say, to display a given frame. And here you can select the frame index. So what will happen? Once I execute the code until here, an image will be shown. And over here you can control the image that will be shown by specifying the frame number. Here I'm just going to use the first frame. But the main question is, why am I doing this? Well, I'm doing this such that I can manually find the coordinates of the coyote body. Once I find the coordinates of the coyote body, I will insert them in the code, and then the code will be able to automatically detect and segment the coyote body and to recognize the coyote body and the background. Good. So let's execute the code, and later on I'm going to explain the remaining part of the code. That is, we are now executing the code to get the coyote points. So let's do that. To execute the code, you need to press Ctrl-Shift-P, and over here you need to search for Python Select Interpreter. And it's very important that you select the Python executable from the virtual environment, and here it is. Okay, and let's run this code, and let's hope that everything will be fine. I clicked over here to run the code. So here you need to be patient, and here we are. Okay, so what do we need to do here? Over here you need to find 2 points on the query body. How can you find the coordinates of these points? Here in this corner you will see the coordinates as I move my mouse over or hover over the image. So here's the first point. Its coordinates are 2696 and y coordinates is 1187. So write this point. And you can also choose another point on the query body. Another point is 2766 and the y is 1158. Perfect. Now memorize these points. Now I will close this window and then I will press Ctrl C over here to stop the execution of my code. Now, what I will do next, I'm going to define an inference state and I'm going to initialize the state. I'm going to specify the video path that's previously defined, and I'm going to reset the state of my predictor object. Where is our predictor object declared? Here it is. This is very important since we want to start from 0. Now you need to specify the frame index we interacted with during the selection of the point. It was the frame 0. And over here we are going to specify the name of the object that we want to detect, or the ID of the object that we want to detect. I'm going to give an object name 1. That is, my query will have the ID number 1. Over here we need to specify the points on the query body. So this is the x and y coordinate of the first point and the x and y coordinates of the second point. And notice how we store them. We store them in a NumPy array. And over here we specify the data type. Okay. Next we need to specify the labels. And over here we call predictor.addNewPoints. That is, we are telling now to SAM2 to add the points. That is, we have manually selected our object, and this is the object that we want to track. And we specify the inference state, we've specified the frame index, we've specified the object ID, we specified the point coordinates, and we specify the labels. Over here, instead of using, for example, 2 points, you can use 3 or 4 points if you want to improve your detection. Okay, now what will happen next? We're going to show the points over here. That is, we're going to simply show the detection points with the mask, and this is very important. This is just initial check that we can at least in a single frame detect the object. Okay, if that's the case, then we don't need to worry about the points anymore. However, if you still see that SAM2 is not able to perfectly segment query from its background, then choose more points over here. Okay, now what do we do over here? Over here we run propagation through the video and we collect the results in the dictionary. Nothing special. This is happening by SAM2. You see here predictor.propagate in the video, you specify the inference states, and then you simply go over the frames and you propagate. Over here is the end of our code. Here we will create the output images. First of all, you need to specify the period in frames that you want to produce. Over here I'm going to produce with a period of 1. That is, every input image will be processed and the output image will be produced. If you specify 5 here, then every 5th image will be rendered. Okay, and over here we define actually the output. And in this for loop we are going to load the image, write the mask on top of that, that is, segment our query with the mask, and we are going to save the masked image in a special file. So here is the file name. It's going to be with the extension PNG, and over here you're going to use the index. Index 1, 0, 2, 3, 5, whatever it is. And we are going to use the function plot.savefig to save the figures. And notice that the figures will be actually saved in the output folder. So let's see the output folder. Where is the output folder? Here is the output folder, and that's the folder we defined previously or created previously. So again, this piece of code from here to here will simply load the original image, and then on top of that image it will draw a mask and it will save the result in this folder, and it will create the output files. Later on we are going to use these output files to glue them together and to create the output video. Okay, so let's execute the complete code. So run here again and be patient over here. Over here, the first screen to select the points, close this, press enter to continue, and now we are loading frames, and this will take some time. So let's wait here in real time and let's see what will happen. Notice over here that I'm having NVIDIA 3090 GPU with 24 GB of RAM. However, we are still not using the GPU resources currently. Okay, the frame 342. Then let's see what happens. You can see the selected points, beautiful, and you can see that Coyotes was perfectly masked, perfect. Then close this, press enter to continue, and now we are propagating and we are doing the same thing over and over different frames, and we are tracking the object through different frames. So be patient over here. And this is in real time. Currently we are using my GPU resources, and I'm having a very powerful GPU, not as powerful as some fancy GPUs, but still enough. And now what's happening? Now we are executing this piece of code, and we can verify that by going to our output folder, and you can see how nicely the output images are created. This is the first frame. This is the second frame. This is, for example, 7th frame, etc. After approximately 10 minutes, around 60 images are created. And over here I have to mention the following. This is a relatively slow process of saving images, and this is mainly due to this command over here, since this command is not optimized for saving the images. There is a more elegant and faster way to save the images. However, in the interest of time, I will not explain it over here. Let's work with these 60 images. The next step is to learn how to glue them together and to create a movie. This movie will be only 2 seconds long. However, I will create even this short movie since I don't want to wait for 370 frames. So let's learn how to do that. First of all, we need to find the output images, so go back to the base folder, and over here we need to go to the output folder, and we can see all the images. So let's glue them together. To glue all the images together, you need to execute this command. You need to call ffmpeg, you need to specify the frame rate, 30 frames per second. Over here you need to specify the input files. You can see how they're formatted. They start with an S character and then they have a number, and this is how we write it over here, and the extension is PNG. And over here we need to specify the codec, we need to specify some other parameter, the frame rate, and over here we need to specify the name of the output file. So let's execute this. And magic happens. You can see, very quick. Okay, so let's see now the output. So here it is. Now if I click on the output, and if I open the output, here it is. Approximately 2 seconds video, around 60 frames. Okay, that's all for today. Thanks for watching.